Good morning, students. Today, again, we are going to discuss another one method called as the Simpson's one by third rule. So then, formula for this rule is integral over again a to b f of x dx. This is equal to h by 3 y naught plus yn. So here we just change the formula y naught plus yn plus 2 into y2 plus y4 plus etc. That means you just collect the an even number, that means y2 y4 y6 etc. You just add that values and multiply that value with 2. Similarly, the next thing, you just collect the odd values, that means y1 y3 y5. Again you just add that value and multiply that value with 4. Okay, so you just again after that you just add all these values, you can get the formula. So this formula is called as the Simpson's 1/3 rule. Okay, so here also h is b minus a by n and or n is b minus a by n. Here one more observation you need to know. So here for, for using the Simpson's 1/3 rule, you must be take that n to be a even number. Suppose if it is an odd number, means the Simpson's 1/3 rule is not applicable. Okay, so now I'm going to using the Simpson's 1/3 rule, I'm going to evaluate this integration. So that integration is 0 to 6, 1 divided by 1 plus x into dx by using this Simpson's 1/3 rule. Here h value is 1. So now for this one, again I'm going to calculate what is the value of a. That means the lower limit of this integration is 0, upper limit is 6. So by using this one, I'm going to calculate what is the number of intervals. By using this number of intervals, only we can say that this Simpson's 1/3 rule is applicable for this one or not. So here, this finding this value of n is very important. So here b minus a, that means 6 minus 0 divided by, here that h value given us 1. So 1. So now we are getting n as 6. So now we can see that the 6 is a even number. So now I can apply the Simpson's 1/3 rule for this problem. Okay, so here that f of x value to be 1 divided by 1 plus x. Now I'm going to find the x values and the corresponding y value to be f of x. Okay, now you just take the first integration value. That means the first lower limit value to be x. So that to be 0 here. Then you just add on that interval length. Okay, so 0 plus 1 is 1, 1 plus 1 is 2. Similarly, you just go up to 6 because the upper limit value to be is 6 here. So therefore, you just go on up to 6. Next thing I'm going to calculate what is the value of f of x by using the formula 1 divided by 1 plus x, because here they are asking to find this value of this integration. So therefore, I can take that f of x to be 1 divided by 1 plus x. Now replace this x value by 0, then you can get the value of f of x. That means 1 divided by 1 plus 0 is 1. Similarly, you just replace x by 1 means I can get 1 divided by 1 plus 2. That means 1 by 2. Similarly, substituting the value of x in this f of x value, I'm just getting the other values in this table column. Next, I'm just naming these values. So here, first value I'm just taking to be y naught. So similarly, I'll keep on naming these values to up to y6. So y1, y2, y3, y4, y5 up to y6 I'm just having. So therefore here n is 6. So therefore it ends with this y6. Now I'm going to use the formula. Now you can see that by using the Simpson's 1/3 rule, I'm just writing the formula based on this one. Okay, so now you can see that just first add the first and last coordinate values. So y naught and y6. So here y naught plus y6. Then plus 2 into, you just collect the even number of terms. So here the even numbers are y2 and y4. Now I'm just collecting that values and adding that values, then multiplying that value to with this 2. Similarly, next thing I'm going to collect the even values, even odd, odd ordinates. That means y1, y3, and y5. Okay, now I'm collecting that one and adding that values and multiplying that values with this 4. Now I'm getting the formula. Okay, so now after this one, I'm just substituting all the values of y0, y1, y2, y3, etc., y6, substituting that values in this formula, I can able to obtain the value of this integration. Okay, so now the final value of this integration is 1.9587. Okay, So in this way, I can find the value of this integration by using the Simpson's 1/3 rule. Here you have to observe the main thing is for applying this Simpson 1/3 rule that n must be even. So this is a very, very important note here.